Aeronautics and Space Report, brought to you by NASA. Launch vehicle number 511 is all together now. 12-day round-trip transportation for Apollo 16, this country's next flight to the moon. It took 4 years, tens of thousands of people, and 6 million parts to build this Saturn rocket and Apollo spacecraft. These are but a few of the major steps along the way.
Well, I think Apollo 16 has the potential to be the greatest mission yet. And of course,
this is John Young, commander of Apollo 16. 41-year-old Young was born in San Francisco and is a veteran of 3 previous Gemini and Apollo space flights.
To learn a very great many things about the moon and about space flight in general. I think it's very important to do this mission because I think it'll add to our knowledge, and any time we can take some of the out of the unknown, we've done a lot.
There are 3 geologic units which we hope to sample in our landing area. One is called the...
Sharing the lunar surface exploration chores with Young will be 36-year-old Charles Duke, a native of North Carolina.
The moon. Neither one of these units have been sampled before, and they comprise 11% of the front surface of the moon, so there will be 2 fairly significant samples.
I think we have conclusively
Chicago-born Ken Mattingly, 36, is command module pilot for Apollo 16. It is Mattingly who will work in orbit around the moon, while Young and Duke carry out the surface exploration.
We'd like to know about the moon. We want to understand the moon's origin. We want to use the moon as a way of understanding the sun's history. And there's an awful lot of information wrapped up. And the problem we've been faced with in Apollo is we have more questions that require specific answers than we have missions. I suppose that's typical of any exploration.
When you look up at the moon, more than 70% of it appears as light areas. These are called the Highlands. Apollo 16 will be the first U.S. moon landing team to visit and take samples from one of these massive light areas.
The distinction for Highlands material is that it's what we think may be the undisturbed or the primordial surface of the moon. If there are open volcanic areas, then certainly the Descartes area represents one of these types. The backside of the moon is predominantly this light Highlands type material. So maybe by sampling what we see on the front side, we'll find out that sure enough we know what 70% of the moon's surface material may be like. And that's how we selected the Descartes feature.
Astronauts Young and Duke will spend 21 hours exploring the Descartes area of the moon during 3 separate trips out of the lunar module. They will set up a series of scientific experiments, including a seismometer to measure moonquakes, a drill to take deep lunar samples, and a special camera telescope that can be pointed outward toward distant galaxies and earthward for a look at the Earth's upper atmosphere.
The 16 mission will be designed in at least the lunar surface part of our mission is much like Apollo 15. We will have 3 lunar surface EVAs. On the first one, the prime objective is to deploy the ALSEP, which is the Apollo Lunar Surface Experiments Package. We have other areas that we're looking for in the geologic context. Large boulders, which we will have to sample for the isotope relationships within units. A large rock that will have an east-west fracture to it, such that we can sample the soil from between this fractured boulder, which shields some of the cosmic rays that only travel north-south on the lunar surface at a very low angle. So such things as this have been developed and are continually being developed, probably pretty close up to flight time, for to enhance the scientific return from our samples.
Color television will play an important role again. As astronauts Young and Duke carry out their lunar surveys, their images will be beamed to Earth.
But I think one of the most important things that the television can do is to demonstrate our mission in operation and demonstrate it so that everybody can watch it. It's just really seldom that people get to watch exploration in progress, and I think that the television is a good way to do that. And I know how much Charlie and I enjoyed watching the Apollo 15 crew in action, and I hope everybody will get the same enjoyment that we got watching us in action.
A fold-away car. That's basically what the Lunar Roving Vehicle is. Here, the astronauts practice deploying the moon car.
When you see the lunar rover on the ground, your first question is, how can that thing possibly be stowed aboard the lunar module? Where does it fit? Well, it is stowed in what we call Quad 1, which is just to the left. As we look out to the hatch, the front hatch is just to the left of the steps. As the public sees it, from the TV camera looking back at the limb, it will be just to the right of the ladder and the porch. The rover can be stowed on the lunar module because it folds up much like an airplane landing gear folds up into the wing of an airplane.
What's it like to drive the lunar rover? Charles Duke describes it.
Since the rover does not have a steering wheel, we steer and apply throttle through one stick, if you will, that sits between the two crewmen. To go forward, you just tilt the controller forward. To steer right or left, you tilt the controller right or left, and the wheels respond. It's a very sporty little vehicle in steering, because with a four-wheel steering, you can turn around 360 degrees within the own radius of the rover. So you get a very tight turn out of it, and which is useful for navigating around craters, but at top speed it makes it a sporty proposition to drive.
Astronaut Ken Mattingly will handle the orbital science and photography for the Apollo 16 flight. In a water tank at the Manned Space Center, Houston, he practiced going outside the spacecraft. During the trip earthward, he'll do just that to retrieve special mapping cameras housed behind the command module. We asked him to explain how he'll do it.
We open the hatch. I'll come outside and put up the television pole. We'll be taking a command module television picture and a 16 millimeter photographic record of the EVA transfer. After we get the camera set up and we start out, Charlie will come up to the hatch, and he will be tending the umbilical that provides me with my oxygen and pressurization. So he'll be standing in the hatch, and then I'll go ahead and start back. I'll go back to the back end of the service module. We have a set of shoes that I can slip into that'll anchor my feet. It leaves my hands free to work on retrieval of the films, removal of the protective coverings. We'll pull out the pan camera cassette. That's the large one. It's about 85 pounds. It's fairly good size. We'll pull it out, and I'll bring it back to the cockpit, pass it in to Charlie in the hatch. He'll pass it to John, and they'll stow it somewhere inside the command module. After I've returned the pan cassette, we'll go back and get back into the what we call the Dutch shoes to anchor my feet, pull out the mapping camera cassette, which is considerably smaller, bring it back to the cockpit, pass it inside.
We also asked Ken Mattingly about the little subsatellite to be launched by the crew.
Now, the thing that makes us so unique is the idea that we can leave this satellite in orbit around the moon, and then the moon goes in its orbit around the Earth, so that during the course of a month, the little satellite with its detectors goes in and out of the magnetic shield that's formed around the Earth. It has a chance to look at all of the solar wind. We can see it when the solar wind is particularly active. We can see it when it's calm. We can compare the results in a known environment with what we see in other interplanetary and deep space probes. I think it's going to tell us an awful lot about not only the solar wind and the magnetic shield around the Earth, but also a great deal about the moon itself.
The payoff from the moon landings is taking place right now at laboratories in the United States and around the world. It is here that scientists are analyzing lunar samples, ranging in size from large rocks to dust and tiny fragments that can only be seen under powerful microscopes. Consider this fragment. As the microscope moves in closer, a crater about 1/10 that of a human hair begins to appear. The pinhole crater more and more resembles the huge moon craters.
Now I think the picture that's emerging is that the moon did have a metallic core, which was formed early in its history, but the moon must have formed under very high temperatures, where at least some of the material was molten. But very soon after this, the outside of the moon was molten, and so we had...
This is Dr. Robin Brett, Chief Geochemistry Branch, Manned Spacecraft Center, Houston.
Due to settling of crystals and so on, you got a variety of rock types formed, and during this time there was an enormous amount of impact from large bodies, some of them as big as the state of Rhode Island, 50, 60 miles across, making these huge impacts, making these huge holes, throwing out debris all over the surface. I think that we're also seeing more similarities with the Earth than we thought we were before, and we are at last, I think, within 2 or 3 years of getting a reasonable sort of evolution of the whole moon. There have been a number of people...
Dr. Brett further explained the Earth-Moon relationships.
Being able to see the early history of a planet rather like the Earth, namely the moon, and having that history obscured on the Earth itself, we can learn a great deal more about the early history of the Earth. What sort of rocks were being formed, how the Earth's crust was formed, what sort of processes concentrated the elements that we find in the Earth's crust. There are similarities among the rock types that we find on the moon and some of the oldest rock types on Earth. And I think this will get us to understand processes on Earth such as the formation of the core, how the crust was formed, and generally push the Earth sciences, the study of our own Earth, ahead enormously through our study of the moon. So studying the moon is not an isolated thing just to find out about the moon itself. It has much, much bigger implications.
The men and machines that will make Apollo 16 possible are nearly ready, with the launch now scheduled for mid-April. Again, the 3 astronaut crewmen and some personal reflections.
The knowledge that we gain about the origin and the evolution of the moon is one of these days going to help us right here on Earth. Of course, it's only one area, but I believe it's an important area, and I guess I'm betting a lot on it.
By us taking these first few small steps into space, we have broken the ground, so to speak, of a new frontier, and much like the old frontier of the West or the challenge of the oceans, from accepting these challenges and going forward, man has benefited from those, and history tells me anyway that there's no question about benefiting mankind from space.
I prefer to believe that challenges, things that are stimulating, are the kinds of things that make societies healthy. I think that you cannot retain a healthy society without giving yourself some kind of a challenge to draw the best out of you. I think Apollo, or the space program in general, is a particularly unique opportunity to do this. This is the first highly technically charged scientific adventure ever to be undertaken in peacetime. Now, there are other large efforts, there are other things like medicine that involve people, but never before have we had a chance to draw together so many people in so many different walks of life on a common endeavor. And Apollo is surely the epitome of that group action for a peaceful endeavor.
This special report brought to you by NASA, the National Aeronautics and Space Administration.